Hey everybody, what I want to go through today is a relatively quick way to reduce radicals, okay? Let's jump in right on the problems you see on the screen. So you take a look at problem 1, and the first thing we should always look to do is, can we calculate? So when you see, hey, square root of 25, we should be good on 5. Okay, where I want your focus to be though, is I want your focus not to be, hey, what number times itself gives you 25, but rather, do you have 2 of the same factor? Because that's what a square root really means. Do you have 2 of the same factor? And within 25, you do, that's 5. That's why it's equal to 5. Okay, take a look at B. Can you calculate the square root of 24? No, not exactly. That's going to require some rounding off. That's an irrational number. But can we simplify it as the instruction says? Yes. Okay, this is your long approach, and I mean long. What you want to do then is factor 24 and see what within 24 can be square rooted. And so if you broke apart 64 and you said, hey, that was 4 times 6, you will notice that you can take the square root of 4, but you cannot take the square root of 6. So you do take the square root of 4, and you have to leave the operation in for what you can't. And there we go, 2 root 6. Okay, that green solution I want you to do in one line. So I'm going to get rid of that green solution, and here is a functional way to work with it. Do the same thing we did in problem 1. Think about a factor tree. So 2 numbers multiply to give 24, 4 and 6. Within that factor tree, look at the ends of the branches. You can take the square root of 4, that is 2. You cannot take the square root of 6. You're done. That's straightforward. I love using factor trees to reduce radicals. Now, the reason why I really love it, I'm going to get rid of that answer again, is what happens if you didn't factor 24 into 4 and 6. Say instead you said, 2 and 12. Well, now you can't take the square root of 2, you can't take the square root of 12, so you try to factor 12 further. And if we factor 24 into 2 and 12, we're likely to factor 12 into 2 and 6. And remember what we asked. Square root means find 2 of the same factor. There it is. The square root of 2 2's is 1 2, and you cannot take the square root of 6. Okay, the reason why I didn't continue to factor 6 is because I know that 6 breaks into 3 and 2. Those are both prime. They do not have 2 of the same factor. Okay, let's jump on to C, and we'll get really quick. Hey, 2 numbers are multiplied to give 18. I am hoping that you chose 9 and 2 because you can take the square root of 9, you can't take the square root of 2. The only difference on this one is you now have a coefficient out in front. So take the square root of 9, that is 3, reduce it or simplify it with the coefficient, so multiply it. There's my 21. That takes care of the 9. Remember, I took the square root of 9. That was 3. What I can't take the square root of is 2. There we go. Okay, 3 examples. I want to tackle one more. Okay, there we go. We've got 5 root 48. If you want to try this one, pause the video and see if we can match up in the end, but otherwise you're coming along with me. If I'm looking at 48, then the best way to factor 48, because it's under a root, is to factor that into 16 times 3. That is going to give me my green solution, the 5 out in front, times the square root of 16, which is 4, cannot take the square root of 3. You would just simplify that, hopefully in one line, down to 20 root 3. Okay, what if we tackled a different factor tree, though? Well, if you were somebody that said, hey, I know 4 is a perfect square. Nice, I want to factor it. Then you're going to get 4 times 12. That's how you'd break apart 48. You can take the square root of 4, you can't take the square root of 12, so you're going to factor that again, and maybe we break that up into 4 and 3. Now you can see your Square root of your 2 4s is 1 4. And now you're just coming in on the 5 times 4. Can't take the square root of 3. There's your 20 root 3 again. I think the only bad decision would be something along the lines of going like, hey, 48 is 6 times 8. Because then it just really forces you to continue to break things down farther than what you needed. Look at how simple that green factor tree is. The nice part is it still gets you there. I have the 5 as the coefficient. I can take the square root of the 4. That's 2. That takes care of that. Then I can take the square root of 2 2's. That's 1 2. The only thing that isn't a perfect square, the only thing that doesn't have a pair, is that lowly 3. Okay, put your 5 times 2 times 2 together. There is your 20 and our root 3. Okay, I am hoping that those quick examples help you out to be able to go through and reduce a radical. Okay, I'm hoping that that helps you with your practice. Best of luck.